So let's have this problem. A discount appliance store is selling 200 television sets monthly. If the store invests X $1,000 in advertising campaign, the ad company estimates the sales will increase to, so this is the sales, N of X is equal to 3X squared minus 0.25X to the fourth plus 200, where X is between 0 to 9. Now remember, X represents the amount invested in the advertising campaign, and N of X represents the number of television sets, okay? So determine the point of diminishing returns. Now the point of diminishing returns, this is basically the point of inflection, okay, where the concavity changes from concave up to concave down. So meaning, what does this mean? This means that we have to find the second derivative, okay? And the second derivative changes from positive to negative. Meaning, if it changes from concave up, the returns here are basically increasing more rapidly. And then here is your point of inflection, and then it changes to concave down. So here the revenue still increases, but at a much slower rate. That's why it's called diminishing returns. Okay, so for letter A, it says, determine the point of diminishing returns. We want to get the point of inflection, and therefore we have to get the second derivative. Of course, we need to find the first derivative first. So the first derivative here would be 9x squared minus x cubed. That's the first derivative. And then we get the second derivative, which is 18x minus x squared, okay? Now we want to find where it changes concavity. So we have to set this equal to 0. So we can factor out the x, and you'll have, this is 3x squared, sorry about that. So minus 3x squared. So we can factor out the 3x, okay? And this would be equal to 6 minus x is equal to 0. So two values for x. X is equal to 0 and x is equal to 6. Okay. Now, if you take a look, we have 2 points of inflection here. However, your lowest boundary here is equal to 0. So that means there is nothing to the left of 0. So 0 cannot be a point of inflection because we do not have any curve to the left of 0. So we don't have a change in concavity. So we can discard the 0 here, okay, and just use x equals 6. So the x value of the point of diminishing returns is equal to 6. Now letter B, show that this is the point of diminishing returns. So that means we have to show that at x equals 6, the concavity changes from concave up to concave down. So we have to use the second derivative sign chart. So here is your 6. That's the point of inflection. So you want to get the sign of the second derivative, and this is from 0 to 9. Okay. So what we want to do is to test a point that's between 0 to 6. And let's say we get f prime of 1. Let's just say 1. So we get 3 times 1, we'll plug it in here, multiplied by 6 minus 1, which is equal to positive 15. So here you have a positive value for the second derivative. Now next, we find or we test a point from 6 to 9. So say, for example, 7, we get 3 times 7 multiplied by 6 minus 7, and this gives us negative 21. So it's negative right here. So that means that the curve changes from concave up to concave down. And so therefore, x equals 6 is a point, the x value of the point of diminishing returns. Okay. Now, for letter C, it says how many televisions will sell at the point of diminishing returns? So meaning when x is equal to 6, what is n of x? Okay. So we have n of 6. How do we do this? We plug in 6 into our x in the n of x function. So we have 3 times 6 cubed minus 0.25 times 6 to the 4th plus 200. And this would give us 524. So 524 TV sets for at the point of diminishing returns. Okay, and this next one, I guess this is the last